Hi everyone, welcome in another session of data analytics. So today we will be understanding about data pre-processing, how we can do the data pre-processing in case of Python and what exactly is data pre-processing. And in the last session, we have already completed about the libraries in Python, the major libraries that we would be needing. And coming down in the code or in the working with the uh, with any of the project, whatever the necessary libraries that would be needed, that we will be discussing then and there. Okay. So the major libraries we have already completed discussing. They are mainly NumPy, Pandas, Matplotlib, Seaborn. They are the major ones. Okay. So we will be understanding now about the pre-processing and eventually we will be moving in. Okay. Sorry, guys. Let me just share my screen first, then we'll start. Okay. So we have to discuss about data pre-processing. Hopefully my voice is audible and the screen is also visible to you. I have a cold, that's why my voice might be choking to you, but kindly bear with it for today. Okay, so data pre-processing, what it exactly means? Data pre-processing is like getting the data ready for studying and for understanding it for the further analysis or further modeling, whatever be the requirement. Based on that, I will be keeping my data ready for the further analysis. Okay. So what we have done before this, we need to understand the data. We need to draw graphs, pattern, everything for proper prediction. Okay. So let's just give an example. Suppose you wash the fruits before eating, right? And you sharpen the pencil before writing anything, right? So these are the major thing. Like before doing any of the major tasks, we try and do something over that part. So same goes down for data. So before doing either model building or going down for further analysis of the data, we need to prepare our data accurately so that it can be taken accordingly. Now, why do we need this pre-processing, right? We basically need pre-processing for many purpose, also in terms of exploratory data analysis as well. That is EDA. EDA, like it's like looking at the data and asking question. Like EDA, basically, I am explaining about EDA. So EDA is like looking at the data and asking question like what is happening, why this is happening, or is something strange out in the data, this kind of thing. Right now, if my data is dirty, confusing, or missing entries are there, wrong entries are there, when we will be performing EDA, it will be giving me the wrong answers, right? So we need to pre-process the data first. So let's take an example so that we can understand it better. So we'll take name, then we'll take class, then we will be taking maths marks. Then we will be taking height. Okay. All of this we will be taking. Now, majorly, the thing is we will be adding some, like taking some of the records, and based on that, we will be using it. Let's take it as Rahul, Asha, next Rohit, next Neha, and again Rahul. Okay. Fine. So we'll take the data here, class as 10, sorry, age as 10, uh, math marks, or we can add here another, like another segment or entire column that will give us age. Okay. So we can add the age as 10. Class also we can keep as 10 or we can just change it to 5. And maths marks, let's keep it as 90. And then about height, let's take it as 140, and that's all, right? So we will be having the exact same data here and here, right? So we will be having it like that. Now, suppose for Asha, the age is missing. We have 5, the class as 5. Next, the maths marks as 85, and going down about height, let's keep it as 135. And for this, we'll keep the height as suppose 138 like that. And for the student Rohit, the maths marks, we will keep it around suppose 300. And the class, we will keep it as 5. And here we will be putting the age as 10. And for Neha, we'll keep it 9. Again, here we'll keep it 4. Here we'll keep it 70. And then we'll keep it vacant. Okay. So this would be my data. We will be just formatted like the basic formatting. And we'll add a color. We'll just update it and we'll make it bold. Okay, so this is my data set. Now, the very first step that is related to pre-processing, that is understanding the data. Okay, understanding the data. Okay, so the thing is, before touching the data, we need to ask it what does each column mean. This is the basic thing about understanding. Touching the data in the sense like whatever my raw data is, I need to first understand it. Then I can do any further arrangement over the data or any further action over the data, over the raw data. So this is my raw data, right? This is my raw data. Now I need to understand what each column mean, what is the data type of each of the column that we need to understand first. The very first thing is the very first column is the name. So that signifies the student name. Next we have age that gives this age of the students. Then suppose we have the class. Here you can see the class column is there, that is which class the students are currently in. Next, math marks, marks of math that the students have scored. And height is would be in centimeter. What is the height of the student that like of this specific student? Okay. Now coming down to the data type. Okay. So we can see the name is a text data type, age, coming down to class, to math, marks, height, all of this are the numerical data type or number data type. To be very specific, they are integer data type because we are not including any of the decimal point up here, not nor we are going for any of the complex values, right? So these are the parts. Okay, now in this step, this is the first step that is understanding about the data. What exactly is there inside the data that we need to understand in details. Without proper understanding of the data, we can't just go ahead with the data. So the very first step would be understanding the data. Now coming down to the second step, that is equal to handling the missing values. Okay, so we need to handle the missing values. So what is there? We need to first find what are the missing values we have got. These are the missing values we have. Like let's just add a color to this and this one. Okay. So the thing is basically here Asha's age is missing and Neha's height is missing. So why missing data is very important up there? Why we need to handle it? The thing is like imagine suppose a teacher checking the marks. Some answer sheets are half empty, right? So that will directly affect the like directly affect the total marks, right? So the result that it will be taking that will totally go wrong. Okay, so that is the major thing that needs to be taken accordingly. If a teacher is writing something and you have written half part of it and half part you have kept empty, so it will like you will get a lesser mark, right? The same thing works here if the data is not accurate. My like if I am doing either modeling over this data or I am doing further analysis of the data or anything I am doing over this data, that result won't become accurate, right? So that needs to be understood accordingly. Now, what are the ways of handling this missing data? So under this, I'll be writing like method one, that is handling missing data, that is like removing the rows. Okay, removing rows. The major thing is if the row is very bad or the data that is there that is very useful and that is missing only. In that case, we don't have any option other than removing the row accordingly, right? If the row is very bad or useless, in that case, we will be removing it. Like if almost everything is of the data is missing, in that case, we will be deleting it. Suppose we have another name as Ajay. Okay. So now here, like let's take it accordingly. Yes, Ajay. Now here all of the values are missing, right? All of these values are missing up here. So what we will be doing? We will be totally taking down this one and will delete it. Right? This is what we can do. Right? Now we will be adding one. So here it has added Control Z. I want it above it. So I'll just insert another row. So yeah, this is how we will be adding it, right? So if majority of the parts of the part is missing, in that case, we will be completely deleting that row. Okay. Now coming down with filling with the average or the mean. The method two is filling the gap or filling with filled with average, or we can call it as mean. Okay, fine. Or the mean value. Okay. So basically what we can do, suppose here the ages are that is 9, 10, and 9, right? So this part, I'll take the average of this part and I'll fill it up here. Okay. So because for Asha, we have only the age part is missing. Class, marks, height, everything is there. So we'll just take the average of it and I'll fill it. So for taking the average, we will be just taking the average and we'll add this and we will be closing that and we'll hit enter. So we have got the value as 9.6667. So we'll take it as 9.7 only. Okay. So this is how we will be just taking the average, like we'll just adjust the value of Asha here accordingly. Okay. Now we need to fill like there is, suppose this is the second case by filling it with the average value. Now, if there is any of the textual column, like suppose any of the name is missing, in that case, how we will be filling it? In that case, we will be just writing fill with unknown. Okay, fill with unknown. Okay. So we will be just writing unknown over there. Okay. In part of anything, we will be, since the name is not known, so we will be putting just unknown over there. Okay. Now we can fill the value like the like the fourth method is we can fill it the most common value, that is we can fill the value with mode. Okay, with the mod value. okay, with the mod value. Method 4, fill it with mod value. Okay, fine. For this, let's calculate the mod value. So it will be 140 only because 140 has been repeated more often. So we will be just filling it with 140. So before that, let's calculate mod and we will be just taking all, closing it and we'll hit enter. Okay, okay, fine. So this is how it is the number with the divisor that should be the form. So it is not that mode specifically. Mode value it is MODE that mode. So MODE mode. Yes, I have taken it wrongly. So I'll add the numbers from here to here and we'll hit yeah, and we'll get the value as mod. Okay. So this is the part by which you'll get the mod value. So here we are using Excel. That's why like I am trying to explain you with Excel. That's why we are doing it. But when we will be writing the code in case of when we will be writing the code in case of Python, you'll be able to know how we will be calculating the mod. Okay. So don't worry on that. When we will be writing there, we can get the details from there. So for height, the mod value is 140. So we will be filling it up with 140. Okay. So this is how we need to fill it up. Okay. Now here about class. Class we have got this 5. That is not the correct one, right? Because here we need to address it accordingly because as you know, in majority of the case when we are thinking it of, we have to fill it with the same number. And also about the data type, if we are checking for class, the data type is integer. And for among all of the data type being integer data type from class, all of the records are having integer, but one we are getting that is not an integer. So we need to replace it with an integer value. Okay. So this is how we need to tackle it. Now, after coming with this, we have the third point that is removing the duplicate. Okay. So what is duplicate data? Okay. The same row, the same data of the row is getting repeated again and again. So here you can see that this Rahul name is appearing twice. The name can be common. Then we'll check the other details also, the age, the class, the marks and the height. We can see everything is same. That means it is a duplicate data. Now, why this duplicate data is bad for our model, for our data to for further analysis actually? So, suppose we are counting the name of student Rahul twice, but initially the number of students is a bit less. Like suppose in a class there are 50 students, okay, and I am taking the count of Rahul twice. So I am getting the count of the total student in a class to be 51, right? That is actually affecting everything. If we are trying to find out the average height, in that case also I'll be getting the error because I need to take the total height plus like I need to add the total height divided by the total number of students, right? So here we should take 50. Instead of 50, I'll be taking 51. That will be affecting my result, right? So we need to remove the duplicate values. Okay, so we'll keep one copy exact and we'll just remove this one. Okay, so I'll just delete it. So we'll get it accordingly. So this is how we will be getting it. Now we have to understand and handle wrong or impossible data. Okay, so the data cannot happen, that cannot be happen in real life, or like a negative age, like any of the number, like anyone living around for 50 years, like 150 years, sorry, not 50 years, 150 years. Any person is living around 150 years. That is way too difficult, right? But it can be possible, but some of the negative age is not possible, right? So that needs to be taken accordingly. Okay, suppose maths marks, the total marks is 100, but here we are getting that for Rohit, the maths marks is 300, because the maximum marks is 100. How can a student get 300 marks out of 100, right? So we can understand there is a human error that has been made here, so the data has been taken wrongly. So this actually matters because wrong data actually is the lying data, right? So we need to fix this wrong data. So either we can replace it with correct value, we can remove the row, or we can ask where the data is actually coming from. So these are the options we are having. Okay. So we need to take it accordingly. Okay. Now coming down with handling outliers. So what is outliers? I guess you all know. So the value that is very different from others. So here you can see the value. If you are checking for all of these values, this 300 is way too more than other values, right? So 300 is an outlier. So why outliers is dangerous in this case? Because it can stretch the graph accordingly and also can break the averages. If my averages are coming around 20, if I am adding 300 and then also taking it accordingly with the average form, it will be just increasing my average, right? So that for that we will be getting the confused EDA analysis and the visuals won't be taking in that way. Okay. So what to do in that case? We need to check if it is a mistake or it is a real data, like we need to validate it. If the data is valid, well and good, we can keep it. Else we have to remove it and we need to replace it with the real value. Okay, so that is the major thing. So this would be the major area. So here how we can fill it, we will be just taking the average and we'll take the average of this, and just a minute. So we'll take the average of this and we'll just hit enter. Okay, sorry. So E6 and E5, E4, E3 and E4. So I'll just hit enter. So we'll get the value as 87.5. So we'll just keep it like that. So we'll just fill it up with the average value. Okay. So, or we can do the forward filling, the value that is there for the preceding student, we can just fill that to the next. That is also a possibility that we can do. Okay. So this is the major part that we have discussed. Now, after handling wrong and impossible data, we have to handle the outliers that we already discussed but forgot to list it up. Next, after that, we need to check it for, we need to fix the inconsistency that is there inside the data. Okay, so what is inconsistency? The same thing is written in different way. Okay, that is inconsistency. Suppose here it was like 5, it was written 5, right? So let me write it 5. Now the thing is, suppose here the class is containing, it is a numerical column, like the data type of class column is numerical, maybe like to be very specific, integer type, and here we have written as 5, FIVE. That is a textual data, right? So all means the same thing, like the 5 is there, but the problem is it is actually written in Word, right? In the sense of like my when my model or my computer is thinking, in that case, this numeric 5 is not equal to this 5 or V, nothing would be equal. So we need to make everything in the same format and we'll convert all to 5 only. Okay. So this is the idea that we need to do. Okay. So now the data is taken accordingly. Now, after this, we have the seventh point, that is encoding categorical data. So what is encoding categorical data means? So what is categorical data? The data that are written in words like gender, boy, girl, class, like 5, 4, they convert to number, right? So we need to understand like we need to understand the text accordingly, and then based on that we need to convert the text to numbers. Why we need to convert the text to numbers? Because my model won't be understanding or my system won't be understanding any of the textual data. My system or my model understand the categorical the numerical data better than the categorical data or the textual data, right? So that is the main part. So we need to convert the numbers to like the text to numbers basically. Okay. So why we need to convert it? Because my system or my model will understand the numbers better and it won't understand the text or the categorical sections properly. So for making my model understand each and everything in details, it is getting converted into numbers. Like let me give you an example. Suppose we have the column of gender. So we have the values as male and female. Now after encoding, the male will come down to 0 and female will come down to 1. Or the vice versa, like male can be 1, female can be 0. Okay, so that we can understand that for this row, male is 1 and female is 0. Right? So this is the major thing that is happening. Next, we have the feature scaling. What is feature scaling? Feature scaling means making the numbers, all of the numbers similar in size. Okay. Now the thing is, suppose here you can see about height. Height is 140, 135, 1838. For marks, it is 90, 85, 70. But age is around 10, 9, like that. Right? So it is actually making a difference in the numbers. So why scaling is needed? Like suppose we have an elephant, we have an ant, and they are running a same race, right? So at the end, we are sure enough that elephant will win because the size of elephant is big and they can cover a much more distance at the same time because of its size, right? So this because of that reason, the elephant will win. But why we are doing the scaling? Scaling will make all of the values smaller and fair in the range between 0 to 1, and so that no features can dominate the other. We like all of the features get equal importance. Based on that, we can take our work accordingly. Okay. So this is the major idea about scaling. Now we have the feature selection. Feature selection. Feature selection means keeping the only the useful columns. Okay. Suppose name doesn't help in predicting the marks, right? I want to predict the marks at the end. The name of the student won't make any difference, right? In that case, what I can do, I can just remove it. Okay. And also about the height. Height of the student doesn't affect the marks they are scoring, or the age doesn't affect the marks they are scoring, right? So why we will be taking it accordingly? Because the major features should get the importance. So that is the major thing. So we'll keep useful columns only. Okay. So why we will be removing the extra columns? Because that will make our EDA more confusing, and the analysis will be slowed down because of the huge data set. After removing it, my data set will feel light, and based on that, we can do the further analysis. Okay. Now coming down to the next one, that is feature engineering. Feature engineering. Feature engineering means making new smart column from the old one. Like suppose we have the unit sold and the price per unit. Then we can just add, like, just a moment. Then we can just multiply them. Like suppose the total units sold is 3, so it's 4, and per unit cost is suppose 10. Okay, so my total sales that has came up would be 40. 10 into 4, that is 40. Total price that we have got, that is 40. Right? So that is the major idea that we need to take accordingly. Okay, so this is feature engineering. So we need to make new columns, like suppose we have install, yes and no, pass, fail, yes or no. Based on the marks, we can do it accordingly. Like the marks is there. If someone's marks is less than, like suppose 30, then the person will fail. And if someone marks is like greater than 30, that person will pass, of course. So from the marks, we can just take this accordingly and create another column that will say is the student passed or failed. Okay. Or from the height we can find out if the student is tall or not that tall, short, or maybe dwarf. Like that idea we can get. Okay. So that comes under the feature engineering. Okay. We will be seeing each one of it in details. Don't worry, we will be going down in the problem, and there we will be understanding each of them in detail. Next, we have the noise removal. 11th one is noise removal. So, what is basically this noise removal? Noise removal is like the tiny useless variation. Suppose we have the height written as like 140.0001, or we have the value written as 139.9999. Okay, so these are the values suppose I have written. So we need to just remove it and take it to a form, so that we can we can just take it accordingly. If we are getting this, like suppose here we are getting the value, like here in age, the value we have kept as 9.7, right? That is okay, fine, we can understand that the value is 9.7. But if the value is coming up around 9.999999, then there would be a problem. The age is like that, so that will actually hide the real pattern and also confuse the model, like why the age is been given like that, right? So for this is how we need to remove it, or we can just take the whole average of it, like the like 9.7, we can directly take it as 10 only, right? So it will be majorly understandable by this part. Okay. So now coming to down to data formatting and structuring. Data formatting and structuring. We are discussing about data formatting and structuring that actually makes the data neat, clean, and organized. Okay, suppose having the same unit in everywhere, we need to validate that and we need to take it accordingly. The same data format should be there everywhere. The same data type should be mentioned in each of the column. Like if the age column is numeric, all of the data should come down to numeric. If it is class, all of the data should come down class. We need to clean the column names as well. If there is any blank or not. If the name is like suppose AGE, like that, right? So we can see all of the other column names are sentence case, but these are all the uppercase. That we need to check, understand, and based on that, we need to just do the changes so that everything have a proper order. Okay. Now after that, we need to finally do the data validation. What is data validation? Data validation means are the values, are there is any missing value after doing the all of the steps? Is there any missing value still left? Is there any duplicate still left? Any wrong data is there? Everything is going correct or not? That is the quality check we need to do. Okay, so before moving down for any further analysis over this data after pre-processing, we need to have a proper check of the data, that is the data are going accurate or not, or is there still any missing value, is there any still any duplicate values left, or is there any wrong values there inside the data, that we need to check and accordingly need to work. Okay, so that is the major quality check that we need to take. Okay, so hopefully things are understandable to you. What is the pre-processing? Now we will be going down with the Plotly Express. We need to understand about what is Plotly Express. We need about like it is of course a library in Python, a tool that actually draws smart, colorful, interactive graphs. The initial cases we have used Matplotlib and Seaborn for visualization, but from now, along with that, we will be also using Plotly Express. Okay, that makes the graph or the plots more interactive and colorful, and at the same time it makes the graph more into it, like it's like it is taking the graphs more interactive, so that we will be doing. Okay, so why do we need Plotly? Suppose we have done any of the bar plots or any of the plots accordingly, so majorly if that is giving down the data accordingly or making it more beautiful, that is more eye catching, right? So that is the major thing that we need to take into. Okay, that is the reason we will be using the Plotly Express. So let's just go deep dive into it so that we can understand each part of it in details. So let me just go here. Yeah. So this is the example of a Plotly Express. So this is the plot we have got. So this is data that we have taken. So initially you can see the data, like the graphs or the each of the bars they have taken, they are really colorful. And we are getting a good idea from it and how it is being made, that is being made using Plotly Express. Now, if I are hovering over each of the bar, we are getting the data security. What this color signifies? Color signifies red, candy is chocolate, number of candies is 3. Now here it is color is yellow, and we have the candy as gummy, and the number of candies is 7. Okay, coming down here, candy cane. So it is the color is green. The candy is candy cane, and the number of candies is 4. So all of like the numbers also we are getting here, right? So all of the details we are getting here. Now your price versus quantity of candies. So if you are hovering over this bubbles, you are getting the details accordingly. So this is an interactive plot. Okay. So this is an interactive plot. So now come down to the code one by one. firstly, what we have done, we have imported plotly.express as px. So we are calling plotly express, and plotly express is a tool like the library basically. If you are mentioning it that way, it's a library of Python. Okay, so px is just a short nickname that we have provided to it so that it can be taken accordingly. Now, instead of writing a plotly.express again and again, we can write it as px. Okay. Now we will be calling it as accordingly as px only. Next, we are calling importing pandas as pd. So we are calling pandas. Pandas, as you know, is a digital notebook, and plotly you can call it as like a like color book like that. And pandas actually helps to store the data in table format that we have already discussed. Now we have done data equals to pd dot data frame. So what it means, you are actually creating a table, and the table name of that table is data. Okay, you can think about data as a like as a thing that is holding the data, like the all of the information it is holding. Okay, so we have taken candy as the key. This column, like the name, like this is basically like this specification is basically a dictionary data type that contains that we are converting it into a data frame. And the name is data, like where we are storing it in the variable name data only. Okay. So candy is the column name, would be the column name in the data frame. Color would be the column name in the data frame. Price would be the column name in the data frame. Quantity would be the details, like quantity would be the part in the data frame. Like in the column name would be the data frame. Okay. So candy, color, price, and quantity would be the column names in the data frame. And all of this like lollipop, chocolates coming down to red, brown, yellow, price 25132, this quantity as 53746. All of this are the records or the values that we are including in the rows under this column names. Okay. So this is how we have just taken a normal data set so for making you understand. So coming down to the candy, so it is a column called candy. It contains the name of the candies, and it is a textual data, like textual data type, like a integer or no, sorry, it is a string data type. Okay. Coming down to color. This column actually stores the color of each of the candy, and we use it later to give the different colors to the charts and all that we can do. And it actually helps how the candy exactly is looking. Okay. Again, this is a string data type. Coming down next, we have the price. So this column stores the price of the candies, and the numbers means like how many, what this lollipop actually cost, what this chocolate actually cost. So that is the pricing. Okay. So this is a numerical data type, that is the integer data type that we are getting. So these are the things that we can measure. Okay. Next, coming down to quantity, like on how much quantity that these things are being sold, the columns actually shows how many candies we have. Like then the quantities actually tell us how we can compare it, like which candy is more, which candy is less. This kind of comparison we can get. Okay. So this is the basic idea of it about the data set. Now we will be just moving it down accordingly. Now we have to take it accordingly. So first we have done a bar plot, a interactive bar plot. So we have taken fig underscore bar equals to px dot bar. So we are calling, like we are just using plotly express here, like px as plotly. So we are telling plotly, please draw a bar chart for me. That is the thing, like basic thing. Yeah. Okay, we are doing fig underscore bar in this chart object. So this is the chart object that we are preparing, like we are doing, and we are thinking it as a like it is actually taking it like that. So px dot bar, that means we want to draw a bar plot. Okay. Now data. Here you can see data, comma, X candy, Y quantity, color is color that we are putting. So what exactly that means? That exactly means as we are using the data table, like the data frame that we have taken that we are using, and X along X axis we are taking the names of the candies, and along Y axis we are taking the quantities. So the taller the bar, the more candies, the quantities of the candy we have got. Shorter bar, that means fewer candies. Okay. So now we have taken color equals to color. That is, the bar will be colored using the color column. That is the major thing that we have taken accordingly. And now after that, we have added the title as candy quantity, and we have used the labels as well. The labels we have taken quantity and the number of candies. So renaming the axis label instead of quantity, we are showing the number of candies. Okay, that is what we are doing. Like instead of quantity, we are replacing it with number of candies. Okay. So now going down to the plot, we have candy quantity, number of candies, and we are getting this candy. Here we are getting this lollipop. Next we are getting as chocolate. Next we are having this gummy, this cane, candy cane, and jelly, all of it. Okay. So hope things are clear to you, like how we have taken it and how the things are going accordingly. Like if you want, I can just run it in this way as well, like Control C, and I'm running it separately so that you can understand it. And let me run it. Okay, it will not work because we haven't run this, so we need to take this as well. Yeah, now let's run it. So you can see we have got the plots accordingly. So we have got the plots in this form. Okay. So this is the major idea that we want to take it here, and we have to just take it accordingly. Okay. Now coming down after line chart, we need to just focus on after line chart, we will be going here. Just a moment. Let me see what next we are having. Okay. This is the bar plot basically. Sorry, not the line chart. Bar plot we have done. Next, we will be going for the scattered plot, right? So we will be just going for the scattered plot. So here also the same thing. So we instead of px dot bar, we have written the scattered. This all the changes we have done. This we are doing according to price versus quantity that we are doing, and here you can see the price versus quantity we have made, and we have the values accordingly. Like here you can see what is the jelly, like it is a jelly, it is price wise and quantity wise. This is how the data is coming up. So price versus how we are giving it, price versus quantity of candies. So the title of the chart that we are giving it like that. Okay. So it is displayed the scattered plot here. And here we are using fig underscore scatter dot show. That is actually displaying the scattered plot. The same thing we are doing with pi. Here we have only replaced it with pi and fig dot pi dot show. And also we have just changed it accordingly. Like along x what we are taking, along y what we are taking, and how we are taking it. That we have just changed it. So we have taken for this one we have just taken it accordingly. The names we have taken as candy and values we have taken as quantity. That means each slice is the candy and each and the slice size, basically what is the size of the slice that we will be getting, like this size that is actually depending on the quantity. Okay, so bigger slice is more the candies. So we can see that we have got the majority for this blue color, that is for gummy. That is 28% we have got it for. Next base is going down this red wine, that is the jelly. That is the major thing. This is again a plot that we have done. Let's see what plot we have done. We have done a line plot. So basically the line, it's been drawn up here that well. We have just yes, we have just plotted it accordingly. The line needs to be drawn here. So that is the major thing that is left, or maybe we have used it in that way. Okay. So here you can see the line chart that we have taken. So here we basically use markers. We wanted the marker. That's why it is coming up like that. Okay. So if we are using it like that, then it won't be an issue. Okay. So majorly that is the case. We have taken it up here. Next, we have just increased the size of the marker. So for that, we have just taken the size as 15 so that it is easily visible. So you can see here it is easily visible for you. Okay, so we have just included the markers. That's why we have just got the markers here. Okay, now we have to go some of the advanced plots that we need to just take it accordingly. So for the advanced plot, the very first one, we have used the scattered plot that we have already taken. Like here, basically what we have done here, you have like we have just taken we have just bring the required tool up here using the libraries and taken a data set that has the student marks along with the student name, student marks, student study hours, and passed or not. That details, okay? And based on that, we have used the scatter plot, the bar plot, the box plot, the line plot, and the sunburst. Okay. So the very first one, as you know, all like the same way as we have done it for this one, we have done it for this one as well. Like the same thing, we have done it for here. Okay. Yeah, we have done it. Now we have just used px.scattered. We have taken like the colored, the study hours and the marks, the color we have taken based on past, and we have just taken the marks accordingly, and we have just taken it, right? So we have got it accordingly, right? And also about here, like we have just taken it, right? Just a moment. Yeah. Here, basically, we have candies, color, price, and quantity. Now, here, in place of color, let me change it with candy. Okay. And let's run it. So we will be getting it the same way, but here we will be not getting the which color it is, which color it is signifying. So it is lollipop, that is this one, and we are getting the number of candies. This is color, we are getting it like that, and this is how we are getting it. Okay, so here we are not taking it with the color, like which each of the color will signify some of the colors or like some of the specific identifications. Suppose here, if in this place, if I am putting about price and I am running it. So you can see here we have got a price chart that is from 5 to 1, like 1 to 5. That is the major pricing that we have got, and accordingly it has changed. The here for lollipop, the number of candies is 5 and the price is 2. Here it is again the colors is also changing and the data is also changing, right? So here you can see the number of candies is 5 and this number of candies is 6. So we are getting the values in the similar range. So here basically uh, here it is 5. Here the price is 2. Sorry, the price is 2 and here the price is price is 2 as well. So we are getting the same color bars. Okay. And this is the color scheme. The lower the quantity, we based on that, or lower the price, based on that, the bars are colored, and we have got a color chart up here. Okay. So this is how the data is getting accustomed. Or here, if I am changing it with, like, we have done it with all. We have done it with candy, we have checked it with color, we have checked it with price and the quantity as well. Okay. So that is the major thing. Like, this is how the colors are using up here. Okay. Like here, if we are putting color, like, just a moment. Like here, basically, if we are putting color, okay. Yeah, now we are getting this. But don't think this color will come according to what color it has been given. So if it is lollipop, we need to get red color. No, that is not the case up here. So here you can see the color wise, what is the color that is mentioning. The bar colors are been differently mentioned. Like, it is like by default, we are choosing this colors. Okay. So basically, here is another one. The first, we have done the interactive scattered plot. So we will be just seeing it. So just see, yeah. So this is the scattered plot. This is the hours, study hours based on the marks. We have got the plots, and the color is basically based on the student passed or not. The green signifies, like, this blue color signifies they have passed, and red signifies not passed. Okay. So anyone who is studying for 4 hours and the marks is around 69, that person actually failed. Okay. And anyone have studying for 4 hours and scoring marks as 78, that person has passed. Okay. So these are the insight we are getting when we are hovering over the plots. So this is a grouped bar chart. You can see here, like, this is the chart that we have prepared, and bar mode we have used grouped. So we are getting the grouped bar chart. So for Alice, like, different number of student, we are getting the subject English. For Alice, the subject science. The marks wise comparison we are getting based on different subjects. So for Alice, the best marks the student has gotten in English. So this student named Bob has got the best marks in math. The student named as Charlie got the best marks in case of science. Okay, so this is the idea that we are getting it from here. Now we have plotted this box plot. So this is actually giving us the distribution accordingly. This is basically for maths. This is basically for science. This is basically for English. So this line actually signifies the median. So for math, the median value is coming out as 85, and coming down to the max value as 92, and the upper fence the value is coming up as 92. Now here, suppose the marks, okay, just a moment. About the marks, let me just increase the marks, like, with some outliers. Okay, I am increasing it around, like, okay, just a moment. I'll just take it this way. I'll just copy it from here to here. And for box plot only, I want the details. So I'll just take it here so that no other things can be taken accordingly. Okay. So I'll just copy this, and I'll just paste this part, and I'll just run it. So you can see here my box plot has changed. Now I'll just make some of the changes, because for the box plot we have used subject wise marks. So I'll just make some of the changes in the marks. So I'll take around, suppose, 120, 140, 200. Okay. Let's take it. Okay. What is the issue? All arrays must be of the same length. Okay, fine. Yeah, because we have taken it accordingly, so we have to take it there. So Control C, Control Z, basically. And here we will be replacing these values with, suppose, 1. 190, 172, 185. Okay. Now let's check it. Now we have got these values like that. Okay. So this is the effect that we are getting for the outliers. See here, my median value is coming up to be 85, right? So we will be getting this accordingly. Like this is how we are getting. So points are outliers that we have taken and the title we have taken it like that. So this is how we are getting these values. So this is the major change that we have got. Now again, if we are changing the values and let's run it. So now see how the values are well distributed. Okay, so this is the major case. So we need to handle it accordingly, the outliers. And sometimes you will get the outliers here. If there is major outliers, you'll get it here in the circle form. So that are the outliers that you can find out. Like these are the outliers you are getting that you can find out. Okay, so after this, we have just, okay, let's just go down. We have taken the student performance across subjects. So the this is student wise details. This is the performance of Charlie. Like it has increased and then a bit decreased. Then we have got the marks of like the details of Alice, like it has stayed uniform. So it was better and then gone down here and then it has increased. So this is how the student performance we have checked. And this is the sunburst chart that you have got. So this actually follows the hierarchy. First, it has divided into based on the student, then the based on the subject, and then the student passed or not, like that, like in that form, how the score is, or like English, yes. Here you can see Charlie, math, yes. Like the labels that we have taken, that is coming down as it accordingly. Okay. So I guess hopefully you have understood how we are working with this Plotly Express. So this is all about it, guys. So we have discussed about pre-processing and then we have discussed how we can work with this Plotly Express. In the next session, of course, we will be covering up with the part of the project. Basically, we will be just taking it a data set from Kaggle and will do the pre-processing over that data set and also will plot the like do the EDA, basically plot the graphs based on that data set that we have taken so that we can take it accordingly. Okay. So that basic part we will be completing in next session. Then we will be directly moving down to the R programming. So R programming won't take much of the time. We will be starting off with the data types of R and eventually we will be moving on and we'll see how we can work with R programming. Okay. So thank you guys for connecting in today's session. We will be joining in the next session and we will be seeing how we can just use it on like we can take the data accordingly and based on that data like a raw data from Kaggle or any of the online platform we can take it and we have to just do the pre-processing over the data and we need to save that file and then we need to do the further visualization. Okay, so that we need to take into account. Okay, so we'll check it in the next session. Till then, keep on practicing, and if you have any doubts or anything, just note it down accordingly. Okay, so thank you everyone. We'll connect in the next session. Bye.